there are few, we know what a triangle is. We know that triangle is a closed figure which is bounded by three sides. So here, these are the 3 points. These are called the vertex. The plural is vertices. So there are 3 vertices, A, B, and C. There are 3 sides. The sides are AB, BC, and AC. And there are 3 interior angles. So this is angle A. We write it as angle BAC. Then we have angle B, which is written as angle ABC. And we have angle C, which is written as angle ACB. So in a triangle, there are 3 vertices, 3 sides, and 3 angles. That is the reason the name is triangle, 3 angles. Okay. Now we have already studied the classification on the basis of the sides. So on the basis of the sides, the first type of triangle that we know is a scalene triangle. What is a scalene triangle? In which all the 3 sides are of different length. So wherein the length of AB is not equal to BC and is not equal to AC. So if you make a triangle wherein the 3 sides are different, then the triangle is said to be a scalene triangle. The second type of a triangle is called an isosceles triangle. Now in an isosceles triangle, any 2 sides are equal. Any 2 sides are equal. So if you draw a triangle, let's say this is a triangle PQR. And if I say that QR is equal to PR, so because the 2 sides are equal, so PR is equal to QR, the 2 sides are equal, so this triangle will be an isosceles triangle. Is this clear, children?
Yes, sir.
Now, in an isosceles triangle, remember this theorem. We will be proving it later, but the angles opposite equal sides are equal. So the 2 sides that are equal is PR and QR. So what is the angle which is opposite QR? It is angle P. And the other side is PR. The angle which is opposite PR is angle Q. So that means in this triangle, angle P is equal to angle Q. So this is also a property of an isosceles triangle. Is this clear to everyone?
Yes, sir.
Yes, sir.
The third type of triangle that you will come across is an equilateral triangle. Children, mute yourself if you have nothing to say. Now, in an equilateral triangle, all 3 sides are equal in length. All 3 sides are of equal length. So a triangle would be something of this type, let's say. This is D, E, F. We always label the vertices of a triangle. All the 3 sides are of equal length. So we can say that DE will be equal to EF, will also be equal to DF. Okay. And what will be the angles? All the 3 angles will also be equal. Is this clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
So because all the 3 angles are equal, so equilateral triangle is also known by the name of equiangular triangle. This is at times in your questions, rather than writing equilateral triangle, the question may talk about an equiangular triangle. So when the name comes equiangular, equi means equal, angular means angle. So the triangle in which all the interior angles are equal, so it is an equilateral triangle. So this is an equilateral triangle wherein all the 3 sides are equal, all the three interior angles are also equal, and the measure of all these interior angles, so angle EDF, which is equal to angle DEF, which is equal to angle DFE, all these three angles is equal to 60 degrees, and this is fixed. Is this clear to everyone?
Yes, sir.
Yes,
So
sir.
these are the three triangles which I have classified on the basis of the sides. Now let us see the classification of the triangles on the basis of the angles. So classification of triangles on the basis of angles. The first that you will come across is an acute angled triangle. Now, what is an acute angle?
The angle which is less than 90 degrees.
Angle which is less than 90 degree, and it is greater than which? What? It is greater than
So 45 degrees.
45 से बड़ा, 90 से छोटा. That is an acute angle.
Sir, it must be greater than 60 degree.
Then zero
Greater than
degree,
6.
lesser than so greater than 0 degree and lesser than 90 degree. Sir, acute angle.
That is correct. So an acute angle is greater than 0 degree. Okay, so an acute angle is greater than 0 degree and it is less than 90 degree. So if all the three interior angles of a triangle is an acute angle, then the triangle is an acute angled triangle. Acute angled triangle. All the three interior angles should be acute. So an acute angle triangle would look like something of this type, wherein this is A, this is B, this is C. If you see all the three angles, they are acute angles. They are greater than 0
E.
degrees and less than 90 degree. So this is an acute angled triangle. The second one is an obtuse angled triangle. Obtuse angled triangle. Now, obtuse angle is greater than 90 degree and less than 180 degree. So, if any one interior angle, any one, if any one interior angle of a triangle is an acute angle, is an obtuse angle, then the triangle is obtuse angled triangle. That means there can be only one obtuse angle. There cannot be two obtuse angle in a triangle, children. Why? Because we know that the sum of all the angles of a triangle is how much? If you add all the angles of the triangle, what will be the sum be?
So 180 degrees.
180. So if there are two angles which are greater than 90 degree, you add them, the sum may be more than 180, which is not possible in a triangle.
Yes,
Therefore, an obtuse angle triangle can only have only one interior angle can be an obtuse angle. You cannot have more than one angle as an obtuse angle. Is this clear to everyone?
yes, sir.
So it would appear something like this. This is PQR, wherein you see angle Q is an obtuse angle. It is greater than 90 degree. But if you see angle P and angle R, they are acute angles. They are less than 90 degree, but obviously greater than 0 degree. So this triangle is an obtuse angled triangle. The third that you may come across will be a right angled triangle. We have already discussed about this right angled triangle while doing trigonometry. Remember? So if any one interior angle of a triangle is 90 degree, then it is a right angled triangle. So a right angle triangle would look like something of this type. This is A, B, C. It is right angled at B. So angle B is 90 degree. The other two will be acute angles. Is this clear?
Yes, sir.
Now in this right angle triangle, which side is the hypotenuse?
Sir, AC.
AC is the hypotenuse. Which side is the perpendicular?
Sir, AB.
How many of you say that AB is perpendicular in this figure? Raise your hand. Sadrup. Only one. Two. Kartike. 3, 4, 5. Piyush, Akash. Okay, 4 again. 5. That's it. Out of 22, 5 children are saying AB is the perpendicular. So the rest are saying that BC is the perpendicular. Is it? Okay, how many of you say that BC is the perpendicular here? I have got 2, Piyush and Vansh. I've got none. So is there no so there's no perpendicular or what? Muni?
Sir, if we see AB as base, then sir, BC can be perpendicular.
So why will I see AB as the base? What did I tell you in trigonometry? Unless and until the point from where I'm looking at the triangle is not defined, we cannot say which side is the perpendicular and which side is the base. Do you remember that? When we discussed trigonometry, didn't I tell you that the perpendicular and base can interchange their places depending upon from where I'm looking at this triangle? If I'm
Yes,
looking
sir.
the triangle from angle A, then BC will be the perpendicular and AB will be the base, isn't it? And if in the
Yes,
same
Yes, sir.
triangle, if I'm looking it from angle C, this is A, B, and C. Now I'm looking from angle C. The hypotenuse does not change because it is the side opposite to the right angle. But if I'm looking from angle C now, so AB becomes the perpendicular and BC becomes the base. So we cannot say which side is the perpendicular and which side is the base unless and until it is given to us from where we are looking at that particular right angle triangle. Okay, so please keep this in mind. And in a right angle triangle, it will always satisfy what? It will always satisfy the Pythagoras theorem. Is this clear? So we know the Pythagoras theorem
Yes.
says hypotenuse square is equal to perpendicular square plus base square. This is the Pythagoras theorem. Any time that you have to prove that a triangle is a right angled triangle, if you cannot find the angle as 90, the other way of proving it is that you show that the triangle, the sides of the triangle, they satisfy the Pythagoras theorem. If this is happening, if the square of one side is equal to the sum of the squares of the other two sides, then in that case the triangle will be a right angled triangle. Is this clear to everyone?
Yes,
Yes,
sir.
sir.
Now
Yes,
there is
sir.
a special type of a right angle triangle also, which is called an isosceles right angled triangle. Isosceles right angled triangle. Isosceles triangle is what? Wherein two sides are equal. Right angle triangle wherein one angle is 90 degree. Right? So if this is a triangle ABC wherein angle B is 90, we know that hypotenuse is the longest side. So it cannot be equal to any other thing. So the two sides that can be equal will be the perpendicular and the base. Isn't it, children? Hypotenuse, it is the longest side. It cannot be equal to anything. But it is, we are talking about an isosceles triangle. So there has to be two sides equal. So the only two sides that are left are the perpendicular and the base. So they will be equal in length. Is this clear?
Yes, sir.
Yes, sir.
And the remaining, the two angles here will be 45 degrees each. If you remember, when we were doing the standard angles in trigonometry, I used isosceles right angle triangle to prove the values of the trigonometric ratios of 45 degrees. Sine 45, cos 45, tan 45. Remember?
Yes, sir.
Yes, sir.
So these are the different types of triangles that you will come across in the chapter. Now we move to certain terms which are associated to triangles. Terms associated to triangles. The first is a median. Now, if this is the triangle, now whenever the question will talk that in a triangle ABC, children, we always draw a generic triangle which will be a scalene triangle. We do not draw an obtuse angle triangle. We do not draw a right angle triangle unless and until it is specified in the question. So agar question mein bolta hai in triangle ABC, that means you will be drawing a scalene triangle. Is this clear to everyone?
Yes, sir.
Yes, sir.
Now, what is the median? In a triangle, there are three sides. Okay, so if you take the midpoint of one side, let's say I'm taking the midpoint of BC, writing it as D. So that means BD is equal to CD. And you join this to the opposite vertex, which is A. So AD is called the median. So median is, it is the line segment. It is a line segment joining the midpoint of one side of a triangle to the opposite vertex. Similarly, AB is the other side. Let's say E is the midpoint of AB. So if E is the midpoint, then AE is equal to BE. And if you join it to the opposite vertex, which is C, this is the other median. Is this clear, children?
Yes, sir.
Then the third side is AC. The midpoint of AC, let's say this is F. So that means AF is equal to CF. If you join it to the opposite vertex, that is B, so we can say that BF here is the median. Now you see all these three medians, they meet at a single point. They are meeting at a single point. They are intersecting at one point. This point is called the centroid of the triangle. Centroid is the center of the triangle. Okay. So this is another term that you can come across. This is called a centroid. So it is the point of intersection of the medians. And it is always represented by capital G. Is this clear to everyone?
Yes, sir.
Yes, sir.
The third term that you will come across is called altitude. Altitude is also known as height. So if this is a triangle, again I'm drawing a scalene triangle. No, I'm not erasing it. I just could not draw a straight line. Let's say this is A, this is B, and this is C. So from A, if you drop a perpendicular to the opposite side, from A, if you drop the perpendicular from the opposite to the opposite side, so this AD is called the altitude of the triangle ABC. And because I'm dropping this on the side BC, so BC will be the base. So when you studied the area of the formula for the area of the triangle, that is, area of the triangle is half base into height. So here height is AD and BC will be the base, because this is the side of the triangle on which I am dropping the perpendicular. So this perpendicular, you see, it's not dividing BC into two equal parts. It is not necessary that the perpendicular that you draw, the 90-degree that you draw, will be dividing the opposite side in two equal parts. This will happen, but only in isosceles triangle and in equilateral triangle. It is not going to happen in any generic triangles. So you cannot say that here BD is equal to CD. That is wrong. Okay, unless and until it is stated in the question or a specific triangle is given to you, you cannot say that the altitude or the height will be dividing the opposite side into equal parts. So when we define the altitude, we say it is the perpendicular from a vertex of a triangle to the opposite side. That's it. It does not talk about that it is joining the midpoint or anything. So it is just the perpendicular drawn. In a triangle, again, if you see, there will be three altitudes that you can draw. So we have drawn one from the vertex A. You can draw the other from vertex C. Let's say this is E. So BE is the altitude. Now when BE is the height, then because I'm dropping it, I've drawn it on the side AC. So AC will be the base. Is this clear? With the height, with the perpendicular, the base will also change in the triangle. So if you are taking the
Yes.
altitude as BE, then because you are taking BE is the altitude, then AC will be the base. You cannot say BC is the base now. Is this clear to everyone?
Yes, sir.
Yes, sir.
Similarly, if you draw a perpendicular from the point C, so this is how the perpendicular would be drawn. Okay, and now because this perpendicular is being dropped on the side AB, so AB will become the base. So in a triangle, there are three altitudes, and all these three altitudes, they again meet at one point, one single point. This point is represented as H, and this is called the orthocenter. So the next thing that you need to know is orthocenter. Orthocenter, it is the point of intersection of the altitudes of a triangle. Is this clear to everyone?
Excuse me, sir.
Yes, beta.
Sir, are orthocenter and centroid almost the same, sir?
Only in equilateral triangle. Only in an equilateral